A couple titrations on this page. First one, this is more like a redox titration. So 0.2865 sample of iron 2 plus ore is dissolved in acid and converted to iron 3 plus by titrating with 0.02645 liters of 0.02250 molar KMnO4. What is the mass percent of iron in the ore? So let's get started. As usual, we have to write the equation. In this case, I will give you the equation because this is a redox titration and we have not quite learned how to balance these equations. So I'll give you the balanced equation for this one, and so all you have to do is figure out the mole ratios and then do the calculation. So 5Fe3 plus Mn2 plus and then 4 water. Okay, so what is given to us is the mass of the ore, which is 0.2865 grams, and then we are given the molarity not of manganate ion but actually potassium permanganate. Okay, that is something to keep in mind. So 0.02645 liters and the molarity is 0.02250 molarity. Okay, for this one. So strategy that we will have, okay, for this one, it's going to be the same, okay, which means that you will go from moles of KMnO4, okay, to moles of manganate, because in our equation we have manganate. Okay, so we still have to start with the molarity of KMnO4 because that's what's given to us, and then we'll go to moles of iron 2 plus because that's what the question is asking, and then we'll go to mass of iron 2 plus, and then from there we go to mass percent. Okay, that's our strategy. So moles of KMnO4. All right, so in 1 mole KMnO4 we have 1 mole KMnO4, we have 1 mole of manganate. It might seem redundant to you that you're doing this calculation, but it's important because in some cases you may have a ratio of 1:2. Okay, and so this is an important part to do. All right, so moles KMnO4 all gone, and now we can start working. Okay, because now for moles of KMnO4 of manganate, the numbers that you need here are 0.02645 liters times 0.02250 moles per liter, okay, of manganate, which is MnO4 minus, okay, and then we'll go to moles of Fe2 plus. All right, so moles of MnO4 minus to moles of iron 2 plus, and for every 1 mole we have 5 of iron 2 plus. I'm going to have to go to the other line, which I try to avoid, but that's not happening this time. Okay, and then so from moles of manganate gone, from moles of iron 2 plus, now we can just go to grams. Okay, so moles of iron 2 plus is 55.847 grams, and remember this is from the periodic table. Again, iron 2 plus is the same as iron, okay, because electrons don't weigh that much. So this is 0.1662 grams of iron, okay, in the ore. And so now to find the mass percent, you will take 0.1662 grams of iron in 0.2865 grams of the ore times 100%, and this is equal to 58.01%, okay, of iron. So that is how you solve this problem. Keep it straightforward. Mole ratio is very important. Hopefully you won't have to worry too much about how many moles of manganate there are in potassium permanganate, okay, but pay attention to it, but hopefully you won't come across it. Okay, next problem then. And this is like a precipitation kind of a titration, but this is still a titration. And how many milliliters of 0.100 molar silver nitrate are required to react with 750 milliliters of 0.250 molar of sodium chromate? All right, and this is a problem similar to what we've done before, but we'll go ahead and do this again anyway. Okay, this will be a refresher also. And so silver nitrate plus sodium chromate, write the equation, and double displacement. So chromate is a divalent ion, which means it is 2 negative. So you get silver 2 over here, or 2 silver ions here, and then we have the sodium nitrate. And to balance it out, we need to have 2 of sodium here, and then 2 of silver here. Okay, all right. So then how many milliliters? So how many milliliters of 0.100 molar AgNO3 silver nitrate are required to react with 750 times 10 to the negative 3 liters of 0.025 molar solution? Okay, so we can find the moles here as we did before. So remember, molarity is moles over liter, so moles is molarity times liter. Okay, so that's what we're going to do over here, and that is 0.01875 moles. Okay, so 0.01875 moles of sodium chromate. Now we do the mole ratio, because now we have moles of sodium chromate and moles of silver nitrate. So for every 2 moles of silver nitrate, we have 1 mole of sodium chromate. Once you have the moles of silver nitrate, we just need to divide that by the molarity, okay, because in 1 liter there are 0.100 moles of silver nitrate. Okay, so there are moles, and we're left with liters, and convert that into milliliter. Okay, that was the final step, and the answer is 375 milliliters. Okay, again, keep it simple, cross out your units, write your units, and then cross them out, and then you should be fine.